Hello students, in 12th standard chemistry, the lesson number 3, that is in the P block elements, we have been discussing many things, and now in this video we are going to discuss about the chemical properties of sulfur dioxide. Okay, my dear students, already we have studied about the preparation and physical properties of sulfur dioxide, and now it's the chemical properties of SO2, that is sulfur dioxide. Okay, mama? Okay. So in this concept, we are going to discuss these headings. The first one is nature, that is nature of sulfur dioxide. Then second one is how does sulfur dioxide react with sodium hydroxide and sodium carbonate, that is NaOH and Na2CO3. Then third chemical property we are going to discuss is oxidizing property of sulfur dioxide. Then fourth one is reducing property. Okay, how sulfur dioxide reduces the other species. Then fifth one is reaction with oxygen. Then sixth one is bleaching action. Okay, mama. So these are the chemical properties we are going to discuss. What are they? The first one is nature of sulfur dioxide. The second one is reaction with sodium hydroxide and sodium carbonate. Then third one is oxidizing property. Fourth one is reducing property. Fifth one is with oxygen. Then sixth one is bleaching action. Okay, ma? Okay, let us see one by one. The first chemical property is nature, that is nature of sulfur dioxide. Okay, mama. So nature in the sense it's nothing but we have to discuss whether the sulfur dioxide is acidic or basic. Okay, so that is where that is the concept we are going to discuss, nature of sulfur dioxide. Okay, mama. Generally sulfur dioxide is an acidic oxide. Okay, so to confirm that, we are allowing the sulfur dioxide to react with a water molecule. So when sulfur dioxide is reacting with a molecule of water, it results the formation of sulfurous acid. The formula for sulfurous acid is H2SO3. Okay, so from this reaction, as a result of this reaction, we are getting an acid as a product. No? So we can say that sulfur dioxide is acidic in nature, so that it is called an acidic oxide. Okay, mama. Okay, then this sulfurous acid, that is H2SO3, it is on decomposition, it forms two different things. One is proton, that is 2H plus hydronium ions, and the other one is sulfite ion, SO3 2 minus. Okay, so moreover what we have to conclude is sulfur dioxide is an acidic oxide since it forms sulfurous acid when allowed to react with a molecule of water. Okay, then second chemical property we are going to discuss is reaction of sulfur dioxide with sodium hydroxide and sodium carbonate. Okay, so this is the second chemical property we have. Okay, what is sodium hydroxide? We know NaOH is the formula for sodium hydroxide and Na2CO3 is the formula for sodium carbonate. Okay, so generally we can say when sulfur dioxide is reacting with sodium hydroxide or sodium carbonate, the products will be either bisulfite. The product will be bisulfite. That is the product we obtain when sodium hydroxide and sodium carbonate reacts with sulfur dioxide gas. Okay, it results the formation of bisulfite ions. Okay, bisulfite means HSO3, that is called as bisulfite. Okay, let us see the reactions. The first reaction is sulfur dioxide, SO2, on reaction with sodium hydroxide, it forms sodium bisulfite. The formula for sodium bisulfite is NaHSO3. Okay, then second one is reaction of sulfur dioxide with sodium carbonate, SO2, when it is allowed to react with sodium carbonate. What is the formula for sodium carbonate? Na2CO3 is the formula for sodium carbonate. In addition, we have to add a molecule of water as a result of this reaction, that is sulfur dioxide on reaction with sodium carbonate, the product will be sodium bisulfite, NaHSO3, along with the liberation of carbon dioxide gas. Okay, mama. Okay, then this sodium bisulfite, it is easily decomposable, and it is on decomposition it forms sodium sulfite. The formula for sodium sulfite is Na2SO3, along with the formation of a molecule of water and sulfur dioxide gas. So this is the second reaction of sulfur dioxide we have discussed. What is that? When sulfur dioxide is allowed to react with sodium hydroxide and sodium carbonate, the products will be sodium bisulfite. Okay, then let us see the third chemical property, that is the oxidizing property of sulfur dioxide. Okay, dear students, let us see the oxidizing property of the sulfur dioxide gas. Okay, so oxidizing property in the sense how this sulfur dioxide oxidizes the nearby spaces, and you are all familiar with the concept oxidation. What is called as oxidation? Either addition of oxygen or removal of hydrogen. That is called as oxidation, isn't it? Yes, addition of oxygen or removal of hydrogen. Here the species they have taken is H2. Yes, that is hydrogen sulfide gas. Okay, when hydrogen sulfide gas is allowed to react with sulfur dioxide, since it is an oxidizing agent, it is removing hydrogen from this H2. Yes, அதாவது sulfur dioxide வந்து ஒரு நல்ல oxidizing agent அப்படிங்கிறதுனால அது பக்கத்து ஸ்பீசிஸ்ல இருந்து ஹைட்ரஜனை ரிமூவ் பண்ணுது. So after removing hydrogen, this H2S becomes free sulfur. Okay, so this is the oxidizing property of sulfur dioxide. When H2S is allowed to react with SO2 gas, it oxidizes the H2S gas into free sulfur. Okay, then second one, addition of oxygen. Magnesium. When magnesium is allowed to react with sulfur dioxide gas, the magnesium will be oxidized to magnesium oxide. Okay, so here addition of oxygen takes place. Oxygen is added to this magnesium, and this magnesium is converted into magnesium oxide, and sulfur dioxide will be reduced to sulfur. So this is the oxidizing property of sulfur dioxide. Okay, the next one, reducing property of sulfur dioxide. Okay, reduction means what? Addition of oxygen or removal of addition of hydrogen or removal of oxygen from any species is called as reduction. Okay, so first one we are going to discuss is reduction of Cl2. Okay, the reactant side la parunga Cl2, but in the product side what do we have? We have HCl. அப்ப என்ன இருக்குது? இந்த Cl2 கூட hydrogen வந்து add ஆயிருக்குது. So addition of hydrogen takes place. So it is called as reduction process, and for this reduction, which is helpful, SO2 is helpful, so it is called as a reducing agent. So in this reaction, SO2 is a reducing agent. It reduces the Cl2 into hydrochloric acid. Chlorine hydrochloric acid இது reduce பண்ணுது. Sulfur dioxide gas வந்து reduce பண்ணி விடுது. Here also there is a water molecule is added. Okay, so SO2 plus 2H2O plus Cl2, which gives H2SO4 plus 2HCl. Okay, reducing property. Then two more reactions we have, that is reduction of KMnO4 and reduction of K2Cr2O7. Okay, dear students, we know the charges of manganese and chromium in potassium permanganate and potassium dichromate. Can you please remember the charges? What is the charge of manganese in potassium permanganate? Yes, it is +7. In the reactant side, the charge of manganese will be +7. Okay, okay, then in the product side, if we look at here, the manganese will be in the +2 oxidation state, and you know how to calculate the oxidation states. If you have any doubt, you refer your 11th standard chemistry concepts. Okay, so when KMnO4 is allowed to react with sulfur dioxide and water molecule, this sulfur dioxide reduces this manganese to that is the manganese +7 to manganese 2+. +7 இருக்கிற manganese 2+ யார் reduce பண்றான்? SO2 reduce பண்ணுது. So here SO2 is a reducing agent. So that we can say this SO2 is a better reducing agent. Okay, mama? Okay. The next reducing property is with K2Cr2O7. Okay. So here what is the charge of chromium? The charge of chromium, let us calculate. Here 2 potassium, so 2 plus 2x, 7 oxygens, so minus 14, that is equal to 0. Then 2 minus 14 means minus 12, so 2x minus 12, that is equal to 0. Then 2x is equal to 12, x equal to plus 6. Okay, so this is the way of calculating the oxidation state of chromium in the potassium dichromate. So here it is in the plus 6 oxidation state. Okay, in the reactant side chromium is in plus 6 oxidation state, whereas in the product side it will be in the plus 3 oxidation. Okay, so in the reactant side it is in the plus 6 oxidation state, whereas in the product side it is in the plus 3 oxidation state. Okay, so the oxidation state of chromium is reduced from plus 6 to plus 3, so it is a reduction process and it is enhanced by the reducing agent, that is sulfur dioxide. Okay, mama, so these are the examples I have been studying to explain the reducing property of sulfur dioxide. Cl2 is reduced to HCl, then Mn plus 7 is reduced to Mn plus 2, then Cr plus 6 is reduced to Cr plus 3. Okay, okay. The next chemical property we can discuss now. Okay, the next chemical property, that is the fifth chemical property of sulfur dioxide, is reaction with oxygen. Okay, when sulfur dioxide SO2 gas is allowed to react with molecular oxygen in the presence of vanadium pentoxide at higher temperature around 450 degrees Celsius, sulfur dioxide will be converted into sulfur trioxide, and it is a step involved in contact process. Contact process step. Contact process is employed for the synthesis of sulfuric acid. Okay, okay. What is chemical property number 5? With oxygen, sulfur dioxide forms sulfur trioxide in the presence of a catalyst vanadium pentoxide at around 450 degrees Celsius. Okay, okay. Then the last and final chemical property we are going to discuss is bleaching action. So dear students, bleaching is nothing but removal of any colored material from the things like wool, cotton or something else. அதாவது கரைகள் சொல்லுவோம்ல, ஏதாவது colored material ஒரு துணிகளை இருக்கும்போது அதை ரிமூவ் பண்றதுக்கு what is used? Sulfur dioxide is used, and that ability of sulfur dioxide is called as bleaching action. Okay, okay. So when sulfur dioxide is dissolved in water molecule, it will result the formation of H2SO4, that is sulfuric acid, along with hydrogen atom, and this hydrogen atom will combine with any colored material. Here X is a colored one. X may be anything, it may be wool, silk or anything that is colored. When it is reacting with this hydrogen, it forms a compound, and that compound is a colorless, so that the color of the material is removed, and it is called as bleaching action. So bleaching action na enna? Removal of the colored things from any material is called as bleaching action. Okay, the colored material will become colorless by this action, and okay, this bleaching action is temporary. அது பெர்மனன்ட்டாவே கலர் போகாது. இப்போ அந்த கலர்லெஸ் மெட்டீரியலை ஓப்பன் ஏர்ல வச்சோம் அப்படின்னா again it will be converted into the colored species. Okay, okay, the colored material will become colorless, and this bleaching action is temporary. சும்மா ஓப்பன்ல வச்சாலே அந்த கலர்லெஸ் material will become the colored one. Okay, mama. Okay, so with this the chemical properties are over. How many chemical properties we have seen? There are 6 chemical properties we have discussed. What are they? The first one is nature of the sulfur dioxide gas. We have seen that sulfur dioxide is an acidic oxide, and it was confirmed by allowing the sulfur dioxide to react with water molecule. As a result, it forms sulfurous acid, so that the acidic nature of the SO2 is confirmed. Then with NaOH and Na2CO3, that is with sodium hydroxide and sodium carbonate. With sodium hydroxide, it forms sodium bisulfite, and with sodium carbonate, it forms sodium bisulfite. Okay, the 2 chemical properties over. Then third one is oxidizing and reducing property. Oxidizing property. So it is a better oxidizing agent. It oxidizes H3S into S, then Mg into MgO. Then reducing property. The sulfur dioxide is a very good reducing agent. It can reduce the Cl2 into HCl, then Mn plus 7 to Mn2 plus, Cr plus 6 to Cr plus 3. Reducing property also we have seen. Then the fifth chemical property is reaction with oxygen. When sulfur dioxide was allowed to react with oxygen, it forms sulfur trioxide in the presence of a catalyst, that is vanadium pentoxide, around 450 degree Celsius. Then finally bleaching action. Any colored material will become colorless in the presence of sulfur dioxide, and this bleaching action is a temporary one. Okay, so with this the chemical properties are over, and now we are going to discuss about the structure of sulfur dioxide gas. Sulfur dioxide உடைய ஸ்ட்ரக்சர் பார்க்க போறோம். இட் இஸ் நார்மலி a bent shape தான். எப்படி இந்த எலக்ட்ரான்ஸ் போடுறது அப்படின்னு பார்ப்போம். இப்போ பார்த்தீங்கன்னா சல்ஃபர் அண்ட் ஆக்சிஜன் ரெண்டுக்குமே 6 எலக்ட்ரான்ஸ் தான். 2 4 6. Here also 2 4 6. ரெண்டுமே ஒரே குரூப் தான். So valence number of valence electron will be same. Sulfur and oxygen both will have 6 valence electrons. இப்போ இந்த சல்ஃபருக்கு பார்த்தீங்கன்னா மேலே 2 இருக்குதா, மேலே 2 எலக்ட்ரான்ஸ் இருக்குது. அப்புறம் என்ன இருக்கும் அப்படின்னா அதை சுற்றி இன்னும் 4 எலக்ட்ரான்ஸ் ஃப்ரீயா இருந்திருக்கும். ஓகேவா? ஸோ எப்படி இருந்திருக்கும் அப்படின்னா இந்த பக்கம் 2, இந்த ரெண்டுமே இந்த டபுள் பாண்ட் ஃபார்ம் ஆகிறதுக்கு இன்வால்வ் ஆயிருக்குது. இன்னும் 2 எலக்ட்ரான் இருந்திருக்கும், இந்த பக்கம் இருந்திருக்கும். ஸோ 2 4 6. இப்போ இந்த ஆக்சிஜன் என்ன பண்ணிருக்கோம் அப்படின்னா in order to fill its octet it will capture these 2 electrons towards itself. அதனால இந்த ஆக்சிஜன் வந்து O மைனஸா மாறும். Since it is pulling the electrons from this sulfur, it will become O minus. This sulfur is losing electron, no? So it will be positively charged. Okay? அப்புறம் இந்த ஆக்சிஜன் அது 2 4 6ல 2 எலக்ட்ரான் எங்க இருக்கும், இந்த பாண்டிங்ல இருக்கும். ஓகேவா? ஓகே. தென் அடுத்தது இதனுடைய ரெசனன்ஸ் ஸ்ட்ரக்சர். we can easily write the resonance structure. எப்படி எழுதலாம்னா இந்த இங்க இருக்கிற 2 எலக்ட்ரான்ஸ் it will be shifted towards this sulfur, so automatically this double bond shifted over this oxygen. ஓகேவா? ஸோ அதனால we are getting this structure. இந்த மூணு பேர் ஆஃப் எலக்ட்ரான்ல ஒரு பேர் வந்து பாண்டிங்ல மாறி இது டபுள் பாண்டா மாறுது. அப்புறம் இந்த டபுள் பாண்ட் இங்க சிங்கிள் பாண்டா மாறி இதுக்கு மேல O மைனஸா மாறுது. ஓகே, ஸோ திஸ் இஸ் த ஸ்ட்ரக்சர் ஆஃப் சல்ஃபர் டை ஆக்சைடு. தென் the sulfur in the sulfur dioxide gas, it undergoes sp3 hybridization, and இங்க இருக்கிற double bond, the double bond between sulfur and oxygen, it arises due to d pi p pi overlapping. but d pi p pi overlapping na என்னன்னா oxygenல the final orbital will be 2p, sulfurல the final orbital will be 3p, அதுக்கப்புறமா 3d இருக்கும். so there is an overlap between the pi orbital of this oxygen, that is p pi orbital, and the pi orbital is of this sulfur, that is t pi orbital. so due to this overlapping, due to the overlapping of d pi 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 orbitals of sulfur and oxygen atoms, what is coming, this double bond is coming in the sulfur dioxide molecule. okay mama? so with this the concept of sulfur dioxide over. okay ma? go through the video and learn well. Thank you.